Let's talk about one-step equations, okay? One-step equation is an equation that contains only one operation, hence the name one step. Just a few examples of an addition one-step equation might be x plus 9 is equal to 12. Well, it's one step because it just has addition in it. The next example of a subtraction would be d minus 2 is equal to 11. Well, it's one step because the only operation in it is subtraction. The next one is, remember when we have a variable and a coefficient or a variable and a number bumped up to one another, it implies multiplication. So 4c equals 36, one step, multiplication. On that last one, f over 17 equals 3. Remember, that is a division bar, so that says f divided by 17 is equal to 3. One operation, one step equation. Let's talk about the steps for solving an equation. The first step to solve any equation is to write the equation down. Step number 2, you need to ask yourself a question. Is the variable isolated? And remember, by isolated we mean, is it on one side of the equation all by itself? Okay? If the answer is yes, all you have to do is do the math, okay? Simply just follow order of operations until there's nothing left to be done. If you answer no, you have to show the inverse operation under both sides of the equation. Now remember, we've already talked about inverse operations and how inverse operations are operations that undo one another. So, step 3 would be to solve. And by solve, I mean whatever the inverse operation is, apply that to both sides of your equation until you get the variable isolated. Let's do a couple of examples of each type. Today we're going to talk about addition equations and subtraction. Our first one is x plus 9 is equal to 35. Well, our variable is x. And what are they doing to x? They're adding 9. What is the inverse operation of adding 9? Well, the inverse operation would be to subtract 9 from both sides. When we do so, a positive 9 and a negative 9 cancel each other out. So that just leaves x by itself. On the other side, we need to do 35 subtract 9, and we'll find our solution. And our solution is actually x is equal to 26. On the equation on the right, it looks a little different because the variable's not leading the equation. We have 12 plus b equals 27. Well, we know from the community property of addition that I can reverse the order. I can change the order of that and look at it as 12 plus b, or excuse me, b plus 12. So if you look at it that way, what are they doing to 12, or b? Here's our variable. What's the operation that's happening? Well, they're adding 12. What's the inverse of adding 12? You got it, subtracting 12. So we're going to subtract 12 from both sides. Again, positive 12 and negative 12 cancel out. That isolates our variable b. And that leaves us with 27 minus 12. So our solution would be b is equal to 15. Notice how in all of our solutions, the variable is included. You always want to put the variable equals your solution. Okay? The next one, let's talk about some subtraction equations. The first one is x minus 11 is equal to 23. Well, is our variable isolated? Well, here's our variable. Is it isolated? No. What are they doing to it? They're subtracting 11. What is the inverse of subtracting 11, or the opposite of subtracting 11? It's add 11 to both sides. So a negative 11 and a positive 11 will cancel out. So x is our isolated. On the right hand side, we have 23 plus 11. So our solution would be x is equal to 34. One more example and then you guys can get rolling on your assignment. So the next one says c minus 17 is equal to 32. Is that variable isolated? Well, where's our variable? C is our variable. Is it isolated? Nope. What are they doing to it? They're subtracting 11. Or 17. What's the inverse of subtracting 17? Of course, it's adding 17. So we're going to add 17 to both sides. And when we do that, negative 17 and a positive 17 cancel out. Our variable's isolated. On the other side, we have 32 plus 17. So our solution is C is equal to 49. I hope that helps. If you have any questions, let me know, and have a great one.